kids, Mr. George here. I'm going to be taking you through the answers for the first set of challenges. So this one here is set number 1 from the Otago Problem Solving Challenge. Hopefully you guys have been challenged this week with the extra maths problems. Some were more difficult than others. So let's start off with problem number 1. So I'll read out the problem first. It says, we can call this year 2010 a double date year, excuse me, because its first two digits, 20, give a number which is twice that given by the last two digits, 10. How many years are there until the next double date year occurs? So let me just take this step by step. So it's saying that the year that this question was put out was 2010. Okay, it was called a double date year because 20 here, the first two digits, double the last two digits. So working out what the next double date year is, you'd need to obviously move up. So the next whole number that's past 20, if we go in years, is 21. If you're choosing 21, it's a little bit tricky to halve it because obviously half of 21 is not going to be a whole number. That's going to be 10.5. So that one won't really work. So after 21, the next year would be 22. So that gives us the start part of our year. And obviously half of 22 would be 11. So we know that the next double date year is 2211. The next part of the question says, how many years are there until the next double date year occurs? So providing that the year currently is 2010, then the problem that we need to work out is 2211 take away 2010, or 2211 take away 2010, and that answer will be 201 years. So the answer for number 1 is 201 years. Okay, moving on to question number 2. All right, question number 2 says, in Ruby's Year 8 class, there are 24 children. There are twice as many girls as boys in the class. How many boys are in the class? So let's write down a couple of the facts. So 24 children. And what else is important here? Twice as many girls than boys. So 2 times girls than boys. Okay, I've got my key information there. Now, the way to work that one out is, I guess you could use a number of methods, but guess and check is one method that is usually a go-to for most people for problem solving. So let's just randomly guess a number so that we can see one that perhaps doesn't work. So let's just say that we started off our guess at having 5 boys. Let's say there were 5 boys. Now we know that there are twice as many girls than boys. So that would mean there are 5 boys and 10 girls. But the key part to the information is that that needs to add to 24. So we can see that 5 plus 10 only adds to 15. So obviously that is not going to be one of our answers. We could do another guess based on that. So maybe we could move it up to 7, for example. Let's say there was 7 boys. Okay, and you guys can work that out in your heads. If I had 7 boys and double that, you should have came up with 14. So imagine there were 7 boys and 14 girls. Now adding those two numbers together, we've got to work out if that totals up to 24, which it doesn't. So it must mean that we need to get bigger. Okay, the numbers are getting bigger as we have more boys and girls in the class. So let's try 8. 8 boys. Double that would be 16. And then if we total those two together, 8 plus 16, that would equal 24 children. So the answer for that one there would be 8 boys and 16 girls. The last part of the question says how many boys are there in the class, so the official answer for that is 8. Okay, that's number 2. Done, moving through nicely. Let's move on to number 3. All right, number 3 says 9 cubes are put together to form the letter F as shown on the right. I'll show you a picture of that. So it's that yellow F there. Let's see, 9 cubes are put together to form the letter F as shown on the right. Then the whole outside of the letter F is painted yellow. If the cubes are then separated, how many of the cubes have exactly 4 yellow faces? Okay, so having a look at this picture here. All right, so this one will involve a little bit of visualizing, I guess. So having a look at this F here, it's a little bit tricky because I've got this in front of my camera. I can't really see it. If we were to think which of these faces, which of these yellow cubes show 4 faces, let's take this first one here, for example, the one at the top. So you'd see that end face, you'd see the bottom one, you'd see the top one, and you'd see the 2 sides. So you can see that this one here would have 5 faces that are yellow. Remember, the question asks us how many faces would be, sorry, how many cubes would have 4 yellow faces. So that first one's an example of one that does not have 4. Okay? And a clue to that is because one of the faces, remembering that a cube normally has 6 faces, one of those faces is stuck on to the other one. So that means that 6 take away 1 will be 5. So that's only 5. So that would be 5 faces that are painted. Right. If you look at the cube beside it, okay, a quick way to do this rather than counting it up is to know that this one, these 2 are stuck together and those 2 are stuck together. So that's 2 faces that are not able to be painted, and 6 take away 2 equals 4. So that would leave the 2 sides, the top and the bottom. So that means that this one here, the second cube along, would have, exactly as the question says, 4 faces that are painted yellow. So that is one of them. Okay. Now the quick way to work that out from there, we can tell that any cube that has 2 other cubes attached to it would have 4 faces that are spared to be painted. So rather than having to count up every single one, we can say that that one has that. We can say that that one there has that one there has that, and that one there has that. Okay, so that's 4. These ones here on the end, we know that the end ones don't work. And then also that one there in the middle of the F, that one you can see is joined on by 3 other cubes. So that would have 3 faces that are painted yellow. Now, we've got 4 so far. The only other one in question is the one in the top corner. Now, if we think about that, same thing here. It's joint on there, it's joint on there. So in 2 places, it's joint on to the letter F, which again means the 2 sides, the top and the back are all going to be available to be painted yellow. So that means that that one there would also have 4 faces. So in total, 1, 2, 3, 4, 5. The answer to that question there is 5. All right, kids, we're now moving into problem number 4, which is this one here. Now, you will notice, if this is the first time you've done these problem solving activities, questions 4 and question 5 are usually the toughest ones. They do require a little bit more thinking, and they are definitely a good challenge. So I have prepared a little bit of working earlier for this one just to save us some time. I'll read the question first. It says, as you travel along a bike trail, you pass through the following towns in order from west to east: Av, Bun, Con, Dam, Eth, and Flow. The distances in kilometers between some of the towns are given in the distance chart on the right, which looks like that. And that's what I've drawn on my board as well. So for example, the distance between Av and Con is 23 kilometers, and between Con and Eth is 22. Okay, so the examples that they have given, if I use my pre-drawn table here, says the distance between Av and Con, so between A and C, is 23, as you can see on that table. And the distance between Con and F, so C and E, between C and E would be 22. Okay, now the key piece of information in this diagram to help us get to the answer is this one over in the corner. All right, 62. That's going to be useful for us to try and work out some of the missing information from these boxes in terms of distances. So looking at this one, the 62, what we can work out, or what we already know, is that, for example, the distance between A, or actually let's look at the 62 first. We know that 62 is the distance between A and F. Okay, so that's the distance between all of the towns together. So let's try and break this into parts. So the first one, between A and C, is 23. Okay, so that's from the first letter or the first town to the third town. Now we might as well use that as our next point. So from C through to E, so from C to E is 22. So by adding those two together, 23 plus 25, that gives us the distance from A through to E. So let's just write that down. So far we have got 23 I should say. 23 plus 22. Okay, and if you add those two numbers up together, that will give you 45. Now that's a pretty good clue in trying to let us work out the distance between the last two towns. Okay, because remember, this one here, 23 plus the 22, that gives us the distance from A through to E, and we need to get to F. All right, because we know that 62 is from A to F. So what we need to work out is what number, 45 plus what number will give us 62. Or you could change it into a subtraction problem and have it 62 minus 45. And if you're pretty handy with your maths, you will have worked out that that equals 17. So now we know that the distance between E and F is 17. So that gives us one part of the information. Okay, now this will get us one step further to finding out the total solution for our problem. Remember, our question is asking us, it's really important to be checking in on the question so that we know that what we are trying to solve is exactly what the question is asking. So the question says, what is the distance between Con and Dam? So between C and D. So this is the box here that we are trying to solve. Okay, that's the one there we need information for. At the moment we've got this one, and we're going to try and get some more information that will lead us to getting the answer for that one there. So let's have a look at what we've got now. Now that we know that that is 17, and we can work out. Now let me just remember how I did this. Okay, so we're trying to work out next this box here. So we're trying to work out what the distance is between D and E. Okay, what is the distance between D and E? Now, if we know that the distance between D and F is 27, okay, and then we also know that the distance between E and F is 17, that gives us a little bit of a clue there. So let me write that down for you. I'm curious to know if you guys did the same. You might have had a different strategy, but this is my approach. Okay, so what was I saying? The distance between D and F is 27. And we know that the distance between D and F is 27. We know that between E and F is 17. So the difference between those two should give us the distance between D and E. So 27 minus 17 will equal, you should be able to do that one in your heads, should equal 10. Good job. And that will give us this box here. Okay, so we're getting closer. Remember, this is the box that we are trying to work out. Okay, so based on that information, we should be able to work out the last piece of the puzzle. Quickly rub that one off. Okay, and we're going to use exactly the same approach as what we've just done then. We know that the distance between C and E is 22. And we know that the distance between D and E is 10. So a simple subtraction problem should give us our answer. 22. Take away that 10. And try and work that one out. Hopefully you have got that one sorted. 22 take away 10 equals 12. And that is our final answer. Okay, I'm just going to check with the question. It says, what is the distance between con and dam between C and D? And you can see that through all of this working here, we've managed to come to our answer, which is 12. Bit trickier, that question, but hopefully you got the right answer. And if you need any help with that one, please put a comment on the channel in problem solving, and I will try and help you through some different strategies so that you can have a better understanding of it. All right, into question 5 next. Now, this one's a tough one. I'm going to stop the video, write some stuff down, and then I'll get back to you soon. All right, team. We're going to move into question number 5 now. Now, before I start, question number 5, this is not an easy question. It is very, very challenging, and I don't blame you if you haven't got the correct answer. But anyway, I'm going to try my best to explain my thought processes in getting the answer that I did, and I would love to hear you describe the strategies that you use in order to get whatever answer you got. So again, just use that channel, the problem solving channel on your class team. I'm quite happy to have discussion about this. Even for me, this question took me a little bit of unpacking and a bit of time. So let's read the question first, look for the key information, and then we'll go through it step by step as best we can. So it says, Sam takes part in a multi-sport event. She can cycle at 4 times the speed that she can run. So I'm just going to jot down some key points as I read them. So the first thing that I want to jot down is that part there. So she can cycle at 4 times the speed she can run. And the way that I have written that for myself is just that cycling is 4 times running. Okay, that's just a wee bit of shorthand there so that I remember it. From there it says, so she can cycle at 4 times the speed that she can run, and she can paddle her kayak at half the speed that she runs. So I'm just going to write down here, kayak equals half of a run. So the same way as I did that one, that's just a little bit of note taking there for me so that I know without writing heaps, I know the main information from the question. Okay, so that's all talking about the speed. So I'll put that in a separate area. Moving on, it says the course is divided so the course is divided so that the cycle section is 2 times as long as the run, and the kayak section is half as long as the run. Okay, so I'm going to write speed here. And then right beside it, I will write the distance. And what was it again? The course is divided so the section is 2 times as long as the run. Cycle section. Cycle equals 2 times r. And the kayak section is half as long as the run. Okay, so I've got a few things there. That's just my note taking so I can make sense of the question. You may have done it differently to me, and as I said before, I'm quite happy to listen to what you guys did. Quite interested to hear about the strategies that you use to solve this or to make sense of the problem. Moving on, the last part of the problem that's super important is that she completes the course in she completes the 77-kilometer course in 5 hours. So that's pretty important as well. 77 kilometers and 5 hours. So there's a lot happening in this question. I think that's the most important bit to acknowledge. There's lots of information. It's one of those really busy problem-solving questions where you really need to unpack it first to have some clarity for you to solve it. So the thing that I did first was I was looking at that last piece of information with the 77 kilometers in 5 hours. Excuse me. So I drew up a bit of a table, and that's just how I went about it. So I was using the guess and check method. Now remember, with guess and check, they are fully calculated guesses. It's not just random numbers that I'm trialing. I usually will take a couple of numbers and then work out from the calculations where my guesses will be. So the way that I did that is I had a table which had cycling, running, and kayaking. Okay, so I've just drawn up a table like this. Right, remember what I'm trying to work out here is the distances of each of the events, okay, or of each of the parts of the race. So the cycling, kayaking, and running. So it says that it's a 77-kilometer course. So I started off by trialing just a random number. So I thought that I would trial, for example, if the cycle leg was 40 kilometers long. Now remember, it says here at the top, on the course length, it says that the cycle is 2 times the run length. So if the cycle length was 40, that would make the run length 20. Okay, I hope that makes sense. And then the kayaking, it said, was half as much as the run, so that would make the kayak 10. Okay, now what I need to do is I need to add those three numbers up, and I want them to equal to 77. Now those three numbers, if you may have already done the maths, equal 70. So I know that I need to increase my distances to make that make sense. So I'm just going to get another number, which in this case I'm going to choose 50 for the cycle. Half of that is 25. And then the kayak, another half of that again would be 12.5. So let's just use these numbers as another example of guess and check. Okay, so 50 plus 25 plus 12.5. So 50 and 75 would be, 50 and 25 would be 75. Those two would make it 87.5. Which, as we know, we're trying to get to 77. That's too high. So what I can work out from that is that using my guess and check method, the actual cycle distance has to be somewhere between 40 and 50. Okay, so looking at these numbers, 70 and 87.5, 77 is roughly halfway between. So I know that my guess has to be pretty close to halfway between 40 and 50. So what I did is I looked at these numbers and I thought 77 was closer to 70 than it was 87.5. So I'm going to try the number 44. Okay, so that was my third guess. We'll write that down, 44. If the cycle leg was 44, half of that, remember, is the run. So half of 44 would be 22. And then half of that again for the kayak would be 11. 44, 22, and 11. And if I added those numbers together, I get 77. Okay, so that's how I got to that part. Now, that was the first part that I decided to work out for this question. So I know now what the race distances are. And I use that to help me calculate the rest of the information. Okay. So this is what my working looks like so far. Alright, so I've got the information there, which has the exact distances for each of the disciplines for this particular race. Okay, what did I do next? It definitely confused me a little bit, this question. It was a good challenge for me. I haven't had a maths problem solving challenge like this for a while. From there, right, so the question says how fast does she run in kilometers per hour? So again, I went with my normal guess and check method, calculated guess and check method. So what I did is I just grabbed a random figure to start with, and then I kind of adjusted my guesses from there. So what I decided to do was I said, if let's just imagine we take a random number like 10, for example. If let's say the run was 10 kilometers an hour, if the run was 10 kilometers per hour, the cycle has to be 4 times that, remember, because the run is 4 times as fast as the cycle. So if the runner was going at 10 kilometers per hour, it means the cyclist was, when she's on the cycle, she's traveling at 40 kilometers per hour. And of course, the kayak is half as fast as the run, so that would make the kayaker be 5 kilometers per hour. Okay, so I just use this as a number to try and work out roughly what the race time would be with that information, because remembering that 5 hours is the race time that we are looking at for this particular question. So the way that I'm going to work that out is I'm going to work out if someone was going 10 kilometers per hour, I want to try and work out how fast they're going per kilometer, because then it will make the maths a little bit easier. So if you're going 10 kilometers per hour, if I take 60 minutes and divide that by 10, that would mean you're going 6 minutes per kilometer. So I'm just going to say PK, 6 minutes per kilometer. For the cyclist, if they are traveling at 40 kilometers per hour, if I go 60 divided by 40, that would be 1.5. So I'm going to say 1.5 minutes per kilometer. And then for the 5 kilometer an hour, if I go 60 divided by 5, that would equal 12. So if I'm in a kayak, I'm going at, based on these numbers, would be going at 12 minutes per kilometer. Okay, now based on this information, I will be able to get some figures when I combine it with this, because I know that this for sure are the race distances, because they add to 77. So if I was going 6 minutes per kilometer for the run, so looking at the run, that's 22 minutes. So 6 times 22 would be, 6 times 20 is 120. 6 times 2, 12. That would be 132. So I'm just going to put run equals 132 minutes. In other words, 2 hours and 12 minutes. Right, so run 132. If I look at the cycle, they're going 1.5 minutes per kilometer. So 44 kilometers, so 1.5 minutes per kilometer would be 44 plus 22 is 66 minutes. That's for the cycle. Okay, and then the kayak is going at 12 minutes per kilometer. So 12 times 11, nice times table there, would equal 132. Okay, now adding these numbers together, 132 and 132 is 264, plus another 66, what would that be, 270, 330. Now I know that 5 hours is 300 minutes, so 330 minutes is 5.5 hours. So I know that that is going a little bit too slow. So I know that the kilometers per hour needs to be a little bit faster in order to achieve a time of 5 hours. Okay, so I will try another guess and check. Let's try now. Let's say if the runner goes at 12 kilometers per hour. Okay, if a runner is traveling at 12 kilometers per hour, that would be 60 divided by 12 is 5, so that's 5 minutes per kilometer. Okay, if the cyclist has to be traveling 4 times that, so they'll be going quite fast, 48 kilometers per hour. Okay, and I guess a fast way, if I look at the relationship between these numbers, I can see that this one here is 4 times less than that. So actually I don't need to do that calculation because I can just go, the smaller number 6 divided by 4 would be 1.5. So 5 divided by 4 would be 1.25. Okay, or an hour and 15 minutes. So they're going at 1 minute and 15 seconds per kilometer. And then the kayak is traveling twice, or taking twice as long per minute per kilometer. So that would be 6 kilometers per hour and 12 minutes. Hang on just a second, just going to make sure my calculations are right. Sorry, 6 kilometers per hour and 10 minutes per kilometer. Okay, so based on this information here that we have got, looking at the first one, if they're going at 5 minutes per kilometer for the run, 5 minutes per kilometer, 22 times 5, that would be 20 times 5 is 100, 2 times 5 is 10, so 110. So it would mean the run is 110 minutes. Now what I'm interested in here, looking at this first one, is the relationship between the numbers, and that actually gave me a little bit of a clue. Okay, so I'll show you what I mean in just a moment. It'll become a wee bit more clear. It definitely did in my mind. Looking at the cycle, so 1.25, remember? 1.25, 1.25, or an hour and 15 minutes. So looking at the cycle leg, 44 kilometers long. So if they're traveling 1.25, that would, a quarter of 44 is 11. So 44 plus 11 is 55 for the cycle. And the kayak was 10 minutes per kilometer and 11 kilometers. So that would be 10 times 11, 110. Now, what then stood out to me was a bit of a pattern that was emerging. And that quite often happens in maths and happens in problem solving. But you can see here that the run and the kayak is exactly the same time. Okay, both of these are 110 minutes. And then the cycle leg here was 55 minutes, which in fact is half of this number. So that gave me a really big clue to help me solve the problem. But if I add up these numbers, 110 plus 110 is 220, and then an extra 55 is 275. So I would need to, if I'm looking at the race time of 5 hours, if the runner is traveling at 12 kilometers per hour, that means that they are going a little bit too fast, okay, because this time is under the 5 hours. So because I've guessed 10 and 12 for the run time, I figure that somewhere in between, which obviously only leaves one number, which is 11. But what I did here is I looked at this time of 5 hours, okay, and then worked it out. If the run time and the kayak time are double the cycle time, and these two are the same, then that would work out to be, so the 5 hours would work out to be 1 hour of cycling, 2 hours of running, and 2 hours on a kayak. Okay, so 1 hour of cycling, 2 hours of running, 2 hours of kayaking. Those three numbers add together to make 5 hours. So that solved that part of the problem. Now going back to the question, which is the last part, how fast does she run in kilometers per hour? So how fast does she run? So I want to look at the run. Okay, she does a 2 hour run. And based on this time, based on our information that we've got from these numbers, we're going to go with the number 11, which is in between the 10 and the 12. Going to this table here, looking at the run, there is 22 kilometers in the run. And if she takes 2 hours to run 22 kilometers, then it must be 11 kilometers for those hours, because 11 times 2 equals 22. So final answer, lock it in, is 11 kilometers an hour. Okay, that's the working there. Like I said, a really complex question. Maybe I made this question too difficult for myself. Be really interested to know how you guys worked it out and if you got the correct answer. So please post your working, strike up any kind of discussion on your problem solving channel, and then we can work through it there. All right, team, good stuff on that first problem solving challenge. Let me know how you went. Cheers.